So redox, there's a couple things you want to know. The reaction redox occurs whenever there's an exchange of electrons. So electrons go from one side to the other. On our exam, this particular quarter, it would be as acids go to bases. Okay, acidic conditions, sorry. I'm making myself a little crazy. I think we haven't done this example, and it's a pretty decent one. Right here, we haven't done this, correct? So you'd want to be able to balance in acidic conditions, identify the what's oxidized, identify what's reduced, write the oxidation half reaction, write the reduction half reaction. Okay, so all those sorts of things, and then write the overall final reaction. These are usually 10 to 15 point problems. So for those people who get it, it will feel like a 3 points because you're just doing the problem that was asked. Okay, so let's try this. First step, separate what looks familiar, what looks similar. So the iron goes with the iron 3 plus, those look similar. And then the manganese are similar elements, separate those out. That's going to be your first step. Okay, then you want to figure out what's oxidized and what's reduced. So I'll do the easy one. Iron goes from +2 to +3. Awesome. Oh, and I'll do the other easy one. Manganese ends at +2. Sweet. You do the hard one. What's manganese right there? Plus, what did you say, 7? Yeah, that's right. +7 minus 2 times 4 is 8 equals a -1. For some reason you didn't get that, make sure to ask me later or ask a TA. All right, so the manganese goes from 4 to 2, so we call to 2, so we call that what? Reduction. A reduction half reaction. Opposite, the iron goes from 2 to 3, so that's the oxidation half reaction. Okay, so iron 2 plus is oxidized, MnO4 or the permanganate ion is reduced. Now, for each one of these, we're going to go through our 4 steps. Let's do the easy one first, which is the top one. Step 1, there's 4 steps, remember. Step 1, you balance whatever's not the oxygen or hydrogen. That's iron in this case, and there's 1 on each side already, so that's done. Step 2, you balance the oxygen, but there's no oxygen, so you can skip that. Step 3, you balance the hydrogen, but there's no hydrogen there, so you can skip that. Step 4, you balance the charge. There is a charge here. We have a 2 here and a 3 here. I'm going to add an electron to which side, right or left? Yeah, if I add an electron over here to the right-hand side, that makes overall the right-hand side +2, and the left-hand side is +2. As long as they're equal, that's good. So the oxidation half reaction is now balanced. Let's go to the next one. The reduction half reaction. Step 1, balance whatever's not oxygen or hydrogen. That's manganese in this case. There's already 1 on each side, so that's balanced. Step 2, balance the oxygen. There's 4 oxygen on the left and 0 on the right. So I add what here? Yeah, not oxygen, but H2O. Water balances the oxygen. Make sure you get that right. I need 4 of them. Some people write O or O2 instead of water, and that's totally way off base. Okay, so make sure you don't make that kind of common mistake. By the way, before the exam, I'll send you a list of all the common mistakes for exam 1. So you know what those are, and hopefully not do that. Okay. So, step 3, balance the hydrogens. Right now, there's 8 on the right, so I need to add 8 in the left. But I don't write an H here. What do I write? Not H2. H plus. Most commonly, people either write an H or an H2. That's not what we want. We want an H plus. Okay, that was step 3, balancing hydrogen. Step 4, balance the charge. What's the overall charge on the right-hand side right now? +2. A 0 from water, a 2 from manganese. What's the overall charge on the left-hand side? Plus what? Yeah, +7. There's 8 H pluses and 1 minus. So +7. So I'm going to add electrons. First of all, which side did electrons go, right or left? left, and how many? 5. Let's make sure that's correct. Okay, so right, that was 7 minus 5, that leaves plus 2, and that equals the plus 2 on the other side, so that's good. All right, now I'm going to get a different pen out. We finished our 4 steps for each. Now we're going to do our simultaneous or consecutive reactions. I need what to cancel? The electrons are what's called the intermediates. They must cancel. So the bottom one I'm going to multiply by 1 and the top one by 5. That allows 5 electrons on each side. Top reaction, electrons on the right. Bottom reaction, electrons are on the left. Those electrons will cancel. And let's see what I'm left over with here. I'm going to write all the reactants first. 5 iron 2 plus ion. I've got 1 permanganate ion. And I've got 8 H pluses. The electrons cancel, so I'm not going to write them. On the right-hand side, let's see what I got. 5 of the ferric ions. I've got 1 manganese 2 ion. And I've got 4 water. Okay, now I look at it and I ask myself, does anything cancel? Can I simplify this in any way? No, I think nothing cancels, so that looks pretty good. Now, what do I do before I finish the problem? What do I do right now before circling my answer and everything? State symbols, yeah. Every ion has what state? Every ion. Every ion is aqueous. So that one's an easy one. If you see an ion, meaning anything with a charge that's not 0, just write AQ after it. They're in water or in solution, so they're all AQ, or meaning in water, literally. What do I put after H2O? L, yeah, meaning liquid. Okay, done. That's aqueous, not aqueous, acidic conditions. How do I know for sure, though, it's acidic conditions? What am I looking at? Yeah, you see this H plus. You need to remember from last class, H plus means acid. So that means this has to be in acidic conditions. I'm done. I've got my 12 points. Okay? Make sure you look before you get to the exam. Look at my practice exams. You'll see I have a certain way of just writing the question so that you can put the answers in it. Make sure you get used to that style before you show up so it doesn't surprise you. Okay, that's redox. Let's move on. Any questions on that before I move on? Yes, in blue.
Why didn't you add water?
Why didn't I add water?
Why did you add water?
Oh, right here? Okay, why did I add water right here? That was my step 2 of my 4th step for every half reaction. I need to balance oxygen. So there was 4 here, I need 4 here. Why water in particular? Because this happens in aqueous conditions. And so water's everywhere. In aqueous conditions, there's not lone oxygen floating around, and there's not O2 floating around. So those are not candidates at all. Likewise, notice I added H plus on my 3rd step. That's because we're assuming this is acidic conditions. Under acidic conditions, there's free H plus to use. There's no H2 and there's no lone hydrogens at all. Is that cool? Yes? How did I get 5 electrons? Right here. Well, before I wrote that, so pretend it's not there for a moment. Before I wrote that, this had a plus 2 on this side. Is that okay? And over here, there was 8 minus 1, or a total of plus 7 over there. They need to be equal, so 7 minus 5 will equal 2. Okay. Good. Anything else? Or move on? Yes. Basic condition was a question that's not going to be on exam 1. So I'll be doing that on Tuesday, talking about exam 2, actually. You'll see me do that. So don't worry about it for this exam. Same question? Okay, good. Let's move on. Got to keep it moving because there's a lot of action going on today. Net ionic equations. I think I have a sample question for you there. Basically, a net ionic equation, you need to use the 3 steps. And that's in your reader. Let me refer to the 3 steps so you can see them. I'll do a brief overview of that. First, it's the top of page 37. You want to write out the equation and balance it. That's your first step. Well, yeah. Step 2, state symbols. How to get the state symbols? There's 2 ways: the solubility rules and standard conditions. And then finally get to the dynamic equation. You have to do that through the electrolytes by canceling out the spectator ions. So you'll see me do this. I'm going to refer to some tables, some things on page 36. So if you have your reader handy, you'll see me referring to those. Okay, I'm going to get out a practice example. At least one, maybe we'll have a chance to do a couple, we'll see. Okay, let's do this one here. Let's zoom out. There we go. That's a pretty typical, we'll do 2. This is one way to write a question. This would be kind of the easier way in my mind to write it out. I'll show you the little slightly harder way in just a second. Okay, so what do we do here? Well, first we do step 1, writing the reaction out. What kind of reaction will this be? Double replacement. That's because you have 2 ionic compounds here. I know they're ionic because I see metals. 2 ionic compounds do a double replacement. That means the silver will go with the chlorine and the nitrate will go with the aluminum. They switch partners. So thus I end up with Ag, which I know is a plus, with a Cl that's a minus, so 1 of each will work to give a neutral charge overall. And then for the other one, I have aluminum. I know that's a 3+ from the periodic table. And the nitrate, that's one of the polyatomics you were supposed to remember that has a -1. To balance the charge here, I need 3 nitrates to go overall of -3 to balance with the aluminum of a +3. Now I need to balance the reaction as a whole. So let's try that. I'm going to start with aluminum nitrate. That looks a little messy to me, so lost subscripts. 3 nitrates, so I need 3 nitrates over here. 3 silver, so I need 3 silvers over here. There's 3 chlorines on each side, and there's 1 aluminum. That looks good. So there we go. That's step 1. I wrote the reaction out and I balanced it. Step 2, all the state symbols. For the state symbols, the first 2 are done for us. So I don't need to worry about them. If they were not done for us, how would I find these state symbols? Solubility rules, which is on page 36 of your reader. This will be given on the exam. Let's zoom out a little bit. Okay, you'll notice that number 1, the silver nitrate, is aqueous. Even if it's given, I'll just show you why. Because of bullet 1, nitrates are aqueous. The second one, which is hard to see right now, the aluminum chloride is aqueous because of bullet 2. It has a halide or a halogen. That's the chloride. So because of that, it's aqueous. So that's why those 2 are aqueous. How about the next 2? Silver chloride, silver 1 chloride. Look at what bullet applies here. Yeah, the second bullet will apply. So it's hard to fit everything on here. Second bullet applies. And would it be an aqueous or a solid? Solid, because there's an exception. The silver 1 with a halide happens to be insoluble or precipitate. Not including these, all the rest would be aqueous, but those 3 cause any halide to be a solid. So I'm going to write that out. This is a solid. Okay, how about the aluminum nitrate? What bullet applies? In the first one, I've got a nitrate again, NO3. Because of the nitrate, it makes it aqueous. AQ. All right, so I've done step 2. I have all the state symbols. After I do that, now I'm going to look at all of these and figure out which one is a good electrolyte. Okay, all but one of these are going to be a strong electrolyte. Which one is not the strong electrolyte? The one that's a solid. So ionic aqueous compounds are all strong electrolytes. Ionic aqueous. Anything that's a solid, a liquid, or a gas are not. Even though this is ionic, it's not aqueous. Aqueous is the key. Not aqueous, so I'm now going to, let's get a different pen color, brown. I will underline all the good electrolytes. There we go. Okay, underlined all the good electrolytes. Now, next to that underline somewhere, I'm going to write out the ions separately. You might wonder, why am I writing out these ions separately? Well, because strong electrolytes separate out into ions in solution. So by definition, they're really in solution, they're just these ions. And you'll see I'm writing a coefficient in front of each of these just to keep track of the number of each of them. Now I'm going to get a different pen color. I'll use black here. You want to look for what cancels on each side. So does the silver cancel? No, you don't see a Ag plus over here. Does the nitrate cancel? There's 3 of them. Yeah, 3 nitrates cancel with these 3 nitrates down here. They're on both sides, so they cancel. That's a spectator ion. Does the aluminum cancel? Yeah, 1 here and 1 here cancels. 1 on each side. Consider the arrow an equal sign. How about the chloride? No. But one other thing does cancel. What's that? The 3. There's 3's on both sides. So just like in math, you can cancel out the 3's. 3 silvers, 3 chlorides, and 3 AgCl, solids. So the 3 cancels. Let's rewrite this and see what's left. There's an Ag plus. What's the state symbol for Ag plus? Aqueous, because it's an ion, it has to be aqueous. Same for chlorine, it's an ion, so it has to be aqueous. And then all I've got left on the right-hand side is a silver and 1 chloride, which is a solid. That is the net ionic equation. Any questions on this? Yeah. The 3 from which aluminum? That one right here? That 3 plus, you mean? Yeah. Became that subscript right there. It still has a 3 plus, yeah, it just means there's 3 of these about to charge. Yeah, I think I had one more I wanted to do. Yeah, feel free to mumble and discuss with your partner, that's fine. I understand I'm going fast, so I just want to get through as much material as possible here. Ooh, yes, I have an awesome one. Ooh, I love this one. Okay. Any questions on this? I'm about to move it. Yeah. Really loud? 3 got canceled. Yes! Yeah, way up there. Yeah, aluminum 3 plus on the periodic table. That's one of those. It's probably 99% of the time 3 plus. How did I get it from the periodic table? Ignore the transition metal, so ignore scandium to zinc. And then the hydrogen column is +1, the beryllium column is +2, and the boron column is +3. That's how. Is that cool? Yeah. Yeah. The 3, that black 3 was when I balanced it earlier. There was a 3 in front of the aluminum nitrate. That's from the balancing. A 3 here and a 3 here. I'm going to try the first one here. First one. You can do the second one with your family at home, okay? I'm not going to do that here. All right. This is what I would consider a more typical question where I write it out in words. Okay, I'll write it out in words. So, barium nitrate, so you gotta write, okay, barium is 2 plus, because it's in the second column. And nitrate, we saw that in the previous problem, it's a -1, so I need how many nitrates? 2, because 2 minus and a 2 plus balance out. The next one is an ammonium phosphate. Ammonium, that's NH4. I know that's a +1, it's one of my polyatomic cations, actually the only one you've learned. And PO4 is what charge? Yeah, -3. So what do I need to have 3 of? The cation, the ammonium. Because 3 pluses and 3 minuses will balance out. There's both of my reactants. They're mixed in solution. What kind of reaction is this? A double replacement. So double replacement means the barium will go with the phosphate and the ammonium will go with the nitrate. So the barium, 2 plus, will go with the phosphate, 3 minus. So how do I balance the charges here? How many bariums do I need? 3, and phosphates? 2. Yeah, basically if you switch the charges, that would give you a +6 for barium, 3 times 2, and a -6 for phosphate, 2 times -3. And then the other thing I get is the ammonium nitrate. Ammonium is +1, nitrate's -1, so just 1 of each is fine. All right, there's my double replacement reaction. I still have to, what? Balance it. Yeah, I'm still on step 1. I'm still balancing it. Start with the barium phosphate. There's a lot of subscripts here. 3 bariums, 3 bariums. 2 phosphates, 2 phosphates. There's 6 nitrates. I need 6 of that. 6 ammonium. That should work. 3, 2, 1, and 6. Okay, that's all that was step 1. Step 2 is the state symbols. So let's take a look at these here. Let's get a different color pen, black. Okay, this one, let's get my, I'm going to move this out of the way now. I don't need that. Let's put this in here. That's as much as I can zoom out, unfortunately. Okay, barium nitrate. What is that? What's the symbol? AQ, what bullet? Bullet 1, nitrates. That means this one has to be aqueous because that has a nitrate. See that? Okay, how about the ammonium phosphate? What bullet? It's aqueous according to, yeah, I heard bullet 1, I have ammonium. Anything with ammonium is aqueous, so likewise this is aqueous. Okay, how about the barium phosphate? What bullet am I looking at here? 5th bullet tells me it's what? A phosphate is solid. Phosphates are solid, so that's a solid right there. Okay? There's another way you could have done the first 2. Do you see how in the question, if you reread the question, I'm going to move this out now. Don't need that anymore. If you reread the question, it says they're mixed in solution. That means they're both aqueous. So, you don't know what the products are, but you know both reactants are aqueous if it says they're mixed in solution. It means they're literally mixing 2 liquids. Okay, now, that was step 2. We got the state symbols. Last step, let's do the, writing the final net ionic. You got to get there through the electrolytes. So, electrolytes, strong electrolyte, yes or no? Yes, aqueous ionic. Strong electrolyte? Yes. It's aqueous ionic. This one? No, it's a solid. This one? Yeah, it's an aqueous ionic. So now, for all those I underline, I will write these out, all the ions separately, because literally, that's what happens in solution. They separate out. That's what it means to be a good electrolyte. So I'm just writing these separately. All 3 of these, kind of squeeze this one in here. Okay, wrote those all in. Now I'm going to see what cancels from both sides. I'll use my black pen for that. Notice the barium cancels, yes or no? No, there's no barium to cancel with. How about the nitrates? 6 of them. Yeah, happens to be 6 nitrates. Wonderful, magical almost. Okay, how about the 6 ammoniums? Yeah, 6 ammoniums over on the other side too. Wonderful. How about the 2 phosphates? No, too bad. Okay, so we've got, let's see what's left. I have 3 bariums, 2 plus, what's the state symbol? AQ, because it's an ion. And then I've got, let's see, 2 phosphates. That has to be aqueous because it's an ion. And then the solid that never dissolves. Barium, Ba3, PO4, 2, solid. And there's my net ionic equation. Okay? That would be a pretty typical example to see on an exam where it's written out in words.